One thing that you hear me say quite frequently in this class is that ecological problems are economic problems, and that therefore they sometimes require economic type thinking. And our book introduces some economic thinking with the idea of natural capital. Natural capital is a combination of resources and ecosystem services to imagine a kind of bank account that we have in nature, the total value of all of those materials that we have as shared property of humankind or shared property of life on Earth that is out in nature. So when we talk about natural resources, we're talking about food, we're talking about water, wood, soil, energy, space, as in the amount of territory that can be occupied, which is a limited resource. Any space that you use for housing development is space that cannot be used for agriculture. Any space used for agriculture cannot be used for natural ecosystems, etc. Minerals and metals that can be pulled out of the earth, plastics, which are petroleum products, medicines you might be able to get from maybe an exotic plant species. So higher biodiversity gives us a higher diversity of different types of products, particularly medical products that we could produce, and ecosystem services. I've mentioned ecosystem services before. I know I did in the first video, so maybe it's about time we got around to a formal definition. An ecosystem service is an amenity provided by healthy ecosystems that humans would have to pay for if that ecosystem was impaired or no longer existed. So what does that mean exactly? Imagine that we have a city, and that city has storm drains, right? You got those grates in the streets for storm water to go into, and then it goes into pipes, and then those pipes lead out to the ocean, right? To get rid of any kind of storm water that prevents flooding in the city. But those pipes are only so big. So there could be an amount of water that rains down on the city that overwhelms the capacity of those pipes, and you get flooding. And we see this. We've seen it in Philadelphia. We've seen it in many other cities where there's so much rain that it floods the city, and you get all this water damage on the first floor of every building in that area. People have to walk around in chest-height water and things like that. If there's a wetland upstream of the city, one thing that wetlands do is they store water. They are slightly low-lying areas, so when water pours in from higher areas, it collects in the wetland first, and then the wetland, if it's upland of the city, it will hang on to that water and prevent it from flooding into the city, which gives the storm drains enough time to get rid of the water in the city before the water in the wetland trickles in. If you were to pave over the wetland, fill it in, and then pave it over to create development land, you no longer have that ecosystem service. It's not going to retain any water because you had to flatten out the area in order to put houses in. So all of the water that rains upstream of the city is going to go directly into the city, and you're going to get many, many, many times the amount of water that the storm drains have the capacity to deal with. So you're going to have more flooding, more and more flooding. What does that mean? It means that the city needs to invest more money in infrastructure for stormwater mitigation. They might actually need to raise the city or build larger pipes, all of which are going to be extremely expensive. It's probably going to require tearing up the road and physically putting larger pipes in. Therefore, stormwater mitigation is an amenity provided by a wetland that humans would have to pay for if the ecosystem became impaired or destroyed. It is an ecosystem service, something we're getting for free just by leaving the ecosystem alone. And that's why ecosystem services are added into this concept of natural capital. We are getting actual monetary value out of healthy, intact ecosystems just by virtue of the fact that they are healthy, intact ecosystems. Another example would be soil retention in forests, that you don't get as much erosion if you have lots and lots of plants holding onto the soil, which means you're not going to have mud and silt going into waterways downstream, which means you don't have to pay for as much water purification. You have a healthier fish population downstream. That's good for fishing industry. You're going to have less worry about topsoil erosion, which is a big problem for farmers, losing all of that fertile soil on top. Speaking of which, you would also have less worry about artificial fertilizers ending up in waterways and elsewhere because they're not going to get washed away with the soil. If you have a forested buffer around coastal regions, you would have less concern about the coastline eroding away to the point where those coastal properties were in danger of falling into the ocean, which would dramatically decrease property value, I would imagine. So natural capital, in a way, is an attempt to calculate what our shared financial investment is in nature, what the total value of all of the products that we could potentially get out of nature is, but added on to that, all of the potential return on investment that we would get by leaving functioning ecosystems alone in terms of ecosystem services. When resources are removed in an environmentally hazardous way or in an unsustainable way, only the people that remove the products and then sell them, or the people that end up using them, are actually going to get the benefit out of that product. Meanwhile, the ecosystems themselves will be somewhat damaged, and the ecosystem services that they provide will be decreased as a result. So that means that someone's more or less made a withdrawal from the bank account, and the rest of our natural capital has decreased. This is a useful conceptual framework for discussing environmental problems because frequently in policy discussions, it's presented as we can either do something good for the environment or we could do something good for the economy. But with the knowledge that some actions are both environmentally and economically beneficial, we can alter that conversation to say, hey, the most environmentally conscious choice is also the one in all of our best interest, economically speaking. So with the idea of maintaining our economy, in addition to maintaining our natural capital, keeping it maximized, we can talk about sustainability, which is conserving Earth's resources in ways that meet the needs of people today without eventually depleting them. One way to do that is to focus on using renewable resources and try to reduce the number of non-renewable resources. Renewable resources are any source of energy or material that can be recycled through biogeochemical processes. For example, hydropower, wind, geothermal, solar, and biomass. Wind is a renewable resource because no matter how much wind power you use, as long as the wind keeps blowing, you can use more wind power. There's no limit to how much wind we could extract from the atmosphere, how much wind power we could ultimately gain. On a long enough time scale, we could just keep doing it forever and ever and ever. As long as the earth keeps spinning and the sun keeps shining, there will still be wind currents moving, and we could still keep putting windmills up to keep extracting it. So it's a renewable resource. It comes back. Hydropower, same thing. As long as there's evaporation causing there to be rain uphill, we can still fill up dams, and that will allow water to flow downhill, and then we can capture electricity from that downhill flow. That's how hydroelectric dams work. Geothermal, as long as the Earth's core remains radioactive, we will still get geothermal energy coming out of it, so we can use that heat in order to generate power or to heat our homes. Biomass is growing products for fuel, so you could grow corn and produce ethanol, which is a burnable product for combustion, or you could just think about wood, growing trees for wood. That is a form of biomass fuel. It's a renewable resource because when you burn it, it combusts, you get carbon dioxide in the air, but that carbon dioxide can then be extracted from the air by new trees, new corn growing up, and then you get this new product and you can keep regrowing it over and over and over again. So it's a renewable resource. There's no ultimate limit to how far you could do that into the future. So it's a non-renewable resource. A non-renewable resource would be something that has a finite amount, that is a limited amount of how much there is on Earth. So sources of energy and material that cannot be replenished once used. Oil is a finite resource. It's a non-renewable resource. Coal is a non-renewable resource. Natural gas and nuclear energy. The first three are fossil fuels. All of them were created over the course of 60 million years. They started out as photosynthetic, like algae and plant material, that through biogeochemical processes went through chemical changes and now occurs deep under the earth, and we can extract them out as these high energy products. Initially, the energy was captured from the sun, but slowly it was converted into these other organic compounds that we can burn for fuel. It takes so long to form those things that as far as human civilizations are concerned, those are non-renewable resources. We're never getting new coal on Earth. There are different estimates for how much longer we could continue burning coal. I saw one that said 50 years, but that is contingent on us burning coal at the same rate, and we have been slowly decreasing the amount of coal we've been burning as natural gas prices have been dropping over time. And if we are decreasing how much coal we're using, then the amount of time that we could continue burning it would increase because we're using it up slower. But no matter what, as we use it, the total amount on Earth is going to continue decreasing. So it has an ultimate limit. There's a point at which we will use it all up, and it will be gone. We're not going to get any more of it. Nuclear is somewhat similar. Uranium, plutonium, thorium, these are radioactive elements in the Earth's crust. They are not formed by natural processes in the Earth's crust. They're actually formed, special science fact for the day, you won't be tested on this, but they're formed in the supernovae of stars when they explode. Our sun is a third generation star. So there are some elements from older stellar explosions that are just in the Earth's crust. So as a result, we're just never getting any more uranium in the Earth's crust. We're never getting more thorium in the Earth's crust. So nuclear energy is another non-renewable resource. That said, unlike fossil fuels, using it all up is nowhere on the horizon. There's enough of it in the Earth's crust, and we use so little of it per reaction that it's not a concern for us anytime in the near future. The nuclear waste generated from nuclear power plants is a more immediate concern, but using up it as a fuel source is not. But that's, again, a topic that we'll talk about later on when we have the whole unit that's just about energy resources. So sustainability would ask us to use as many renewable resources as possible in a responsible way so that we are not pulling things out of the environment faster than they can be replaced, while using as few non-renewable resources as possible. Because when you remove a non-renewable resource from ecosystems, it cannot be replaced. So that's a permanent withdrawal from our shared natural capital. But like I say, even overuse of a renewable resource can lead to negative consequences, and this leads us to the concept of the tragedy of the commons. This is meant to describe a situation where the number of users of a resource is large, and perhaps if everyone used exactly their share of that resource, then since it's renewable, it would be able to replenish itself and it would be fine. But if everyone uses just a little bit more than their share, then eventually they will deplete that resource to nothing and it will disappear. So it is the cumulative degradation due to overuse of open access renewable resources and shared resources such as forests and streams. I would even add on to that shared resources such as the atmosphere, a open access resource that we all are constantly interacting with at all times. It occurs when individuals in a group incorrectly believe that the little bit that I use or pollute is not enough to matter, and anyway, it's a renewable resource. Yes, renewable resources come back, but they can be depleted, as I mentioned in the first video. You can hunt a species to extinction such that it won't come back. You can cut down enough trees in a forest that there is no forest anymore. You can put enough pollutants in the atmosphere that there is a point of no return. That last one, a very scary concept that we will talk about again later on. The original idea with the tragedy of the commons went like this. You have this large grassy field, which we call the commons, and there are 3 sheep herders, and they each have a sheep, and they let their sheep go out and graze on this field, and it's good. There's enough food for all 3 sheep to be able to graze, and they leave their waste on the field, and that's fine because it washes out, it acts as fertilizer, it's okay. There's the field can deal with that much waste from 3 sheep grazing on it and leaving their droppings. It works just fine. But this is a shared resource. None of the sheep farmers really own it, or you could say that they all equally own it. One of the sheep farmers realizes that if he got a second sheep, he could get all of the profit from that second sheep, all the profit from the wool, or if he's raising it for meat, he could sell the excess meat. He'd get 100% of the profit from utilizing that second sheep. but the costs in terms of the food, which is coming from the grass, and the waste, right, the added amount of waste, which is depleting, which is damaging the ecosystem, that's going to be distributed amongst all of the herders. So he gets 100% of the profit, but only 1/3 of the ultimate costs of that new sheep. So he is economically incentivized to do that. He gets an extra sheep. But the other farmers see this and they say, hey, he's using twice as many resources as the rest of us are. That's not fair. So you know what? In order to make this fair, we should each also get another sheep. At least then we are all sharing the burden of this extra sheep equally. But now there's twice as many sheep as there were, and the field can no longer sustain the amount of herbivores that are eating this grass or the amount of waste that's being produced covering it. So the entire ecosystem collapses and all of them lose their sheep. They no longer have a place to graze them because it's all gone. That's the idea of the tragedy of the commons. When an opportunity presents itself for someone to get 100% of the benefit of an action but distribute the costs amongst everyone using that resource, they are economically incentivized to do so. So say we had a mountain that supported a vibrant ecosystem. People use it for recreation, people use it for camping. It has a number of species, rich biodiversity all over it, species maybe you can't see interacting together anywhere else on the planet. And we find out that there's a whole bunch of coal in seams underneath that mountainside, and it gets sold to a prospecting company, and they end up blowing the side of the mountainside off. So the company that extracts the coal can keep 100% of the profit from selling that coal. But the loss of ecosystem services and the loss of that space as recreational space and the loss of the air quality and soil retention and all the other benefits that that ecosystem could have provided, the loss of the animals and plants there, is distributed. It's taken out of the natural capital that we all share. And that's the value of natural capital as a concept. It allows you to do cost-benefit analysis. It allows you to talk about potential profits from some action versus potential costs using the same language. You're talking about investment. You're talking about capital. So to expand on natural capital, let's talk about one component of it, which is ecosystem services, in a little bit more detail. Currently, as I've mentioned before, the human population is growing, and as it expands, it's also becoming more urbanized. More people are living in cities, and that means that the cities themselves are actually growing. We call this urban sprawl. In order to make more room for more housing development, more parking lots, more roads, more infrastructure, we need to get rid of a lot of the natural habitat that was already there in order to spread ourselves out. And this means that we are losing a lot of those natural ecosystems. We are losing the ecosystem services that they provide. So there is a certain cost to this expansion. The average annual value of ecosystem services each year in the United States is more than $33 trillion. There are economists who just dedicate themselves to trying to figure out how much money we are getting from nature. That sounds like a fun job to me, but I'm a very particular type of dweeb, so maybe that doesn't sound like fun to everyone. So you say $33 trillion, can that possibly be right? Well, to give you an idea of where those numbers are coming from, here is some data from the U.S. Forest Service, and this is just for U.S. forests alone. So no other type of ecosystem, nothing else considered, just forests in the United States, and the ecosystem services that they provide annually. Starting out with cultural services. Cultural services comes in at about $1 billion annually. Now, what are cultural services? These are the hardest actually to pin down. So it's the smallest number on this chart, but it's also the hardest one to actually evaluate. Cultural ecosystem services are the non-material benefits people obtain from nature, including aesthetic enjoyment, physical and mental benefits, and spiritual experiences. And overall, having increased access to natural areas to walk around in decreases stress, it increases productivity, and it improves our overall sense of well-being. How you can put a dollar amount to that sort of mindfulness, I'm not really sure. Perhaps they're comparing it to other services that do cost money with similar sorts of effects. But the economists have come to about $1 billion for cultural services annually. Next up, biological control. Biological control is the control of pest species using predator species. So simply by having an intact, healthy forest ecosystem around, you're going to have a number of different birds. You're going to have toads around. You're going to have predatory insects around. And if you have, say, farmland nearby that periodically gets invaded by, crop weevils or something like that that'll attack your crops, well, simply having a forest nearby will have lots of predators like birds that might come through and be able to eat those insects for you. And if they're removing some of those pests for you, then you don't have to spend as much money on pesticides and removing those pests. So biological control is a sort of pest reduction influence that healthy, intact ecosystems provide for free. And it's equivalent to about $2 billion a year annually. Soil. Topsoil is a slowly renewable resource. It's something we need for agriculture. It's that rich loam, that dark, rich loam that you get at the very top layer of mature forests. And that soil production is big industry. So topsoil comes in at over $2 billion per year from U.S. forests. Materials, in terms of lumber and other materials we could get from forests, comes in at about $5 billion a year annually. Recreation, we're talking about camping, we're talking about people going kayaking and hiking. And have you ever been to a camping store, like a supply store? Some of that equipment is very expensive, and people are willing to pay money for campsites to go out there. They're willing to get like a camper and things like that. They're willing to invest money to go out into nature and be in the woods and enjoy themselves for a week or a weekend or whatever it is. Recreation is big money. It's coming in about $8 billion a year annually. All that money is going into the economy. Food that we get from U.S. forests in terms of game and fruits and nuts and things like that, we are coming in at over $10 billion per year. Waste treatment, I've talked about the water purification that forests provide for free before the water ever makes it to water treatment plants. That comes in at over $18 billion per year annually. And climate regulation, this is in terms of decreased CO2 that's been pulled out of the atmosphere by U.S. forests annually, that is therefore not going into the atmosphere. And since it's not going into the atmosphere, it's not contributing to climate change right now, which is slowing down the overall rate of climate change, which means it builds us a buffer, more time we have to deal with this problem. And therefore, the infrastructure changes that we'll need to make, the expensive costs that are coming, can be delayed a little bit. So it saves us about $18 billion per year, is what they're calculating that based on. Again, climate change is something we'll talk about much later on. Unfortunately, a lot of topics in this course are connected to many other topics in this course. So early on, you'll frequently hear me say, we'll talk about that more later on. But we will get to it, I promise. So healthy ecosystems purify air and water, and they decompose waste and they recycle nutrients. And wetlands buffer coastal populations against hurricanes. They reduce the impact of flooding rivers and they filter pollutants. Healthy ecosystems provide services, amenities, to human populations for free, that if we got rid of the ecosystem, we would have to end up building some technology or building some infrastructure to make up for that service. And that would cost us a lot of money. The book lists a few ways in which our natural capital is degrading over time. It is shrinking. Our investment in natural ecosystems is being depleted steadily. It cites air pollution as one way that it's being depleted, and air pollution is related to climate change. Soil erosion, as we lose some of these ecosystems, their ability to retain the soil is also decreased, so we are losing large sections of that topsoil. It's being washed away. Shrinking forests and decreased wildlife habitats, and that is then tied to species extinction. Declining ocean fisheries. I've mentioned before that we can overfish a population to the point where it's no longer able to replace itself. And yes, for some fish species, we are in fact trending them towards extinction. Water pollution, which is not helping the ocean fishery situation either. and aquifer depletion, where we are pumping water out of wells, out of groundwater, faster than the rain can naturally replenish the groundwater. Groundwater is replenished when rainwater trickles down through the soil and through the rock layers in order to get in there. So when we pump it out faster than it can be replaced, we slowly deplete it. Now, why is our natural capital disappearing? Well, that has to do with the root causes of environmental problems that we talked about in the first video. One of which was affluence, which allows people to purchase or generate more products than are needed to survive or thrive. So it creates a lot of excess. Way more products are used, which means more resources are taken than are strictly required, which means more waste is produced than was required per person. And another one being population growth. There are simply more people on the planet today than there ever have been before. Chapter 1 also introduces the idea of an ecological footprint, which is the relative number of resources that you personally extract from the environment. So this is the way I conceptualize the ecological footprint. Imagine you live on an island, and you live on that island in your current lifestyle, exactly as you live today. You're not making any changes to how you live, you just now live that way on this island. So if you drive lots of places, that's great. You can still drive lots of places on this island. In fact, you will drive just as much as you currently do. But all of your resources need to come from this island. So if you're using up a lot of gas, that gas needs to be coming from this island. So you're going to need an oil field. You're going to need some sort of oil refinery plant that's pulling up and extracting oil in order to make that amount of gas to sustain you. If you eat a lot of foods that are imported from distant places, or are getting a lot of, like, say, clothing or other types of products imported from distant places, well, you would need to fuel up planes and boats that are shipping them to you. So that would increase the amount of gas that you need to be creating on your island in order to sustain that lifestyle. If you wear a lot of cotton clothing, you're going to need a plot of land to grow that cotton in order to make that clothing. If you are eating a vegetarian diet, you're going to need to have a plot of land set up for all the vegetables you are going to be growing. If you eat a lot of meat, you're going to need a plot of land, probably much larger, for the amount of vegetables that you're going to be growing to feed to the cattle that you are then going to be consuming, in addition to the plot of land for probably some additional vegetables for vitamins and minerals for yourself. So the amount of space you need for food production will be much larger. If you live in a big house, you need somewhere on the island where there's a forest to grow enough lumber in order to build up that house. Every single product and amenity that you use needs to come from this island. So the question of the ecological footprint is this: how big does your island have to be in order to sustain your current lifestyle? If you live a relatively simple life, you're walking a lot of places, you're eating, mostly vegetables, you don't buy a lot of new products, you wear your clothes till they're threadbare, all that, you're not going to be consuming a lot of resources. So your island, your ecological footprint, your overall impact on the environment is going to be pretty small. Whereas if you are eating a lot of lavish things, imported materials, you're wearing new clothes, buying them all the time, buying lots of new products, driving all over the place or jet setting around, your ecological footprint is going to be quite a bit larger. So you're going to need a bigger island for that. If you were to add up all of the ecological footprints of all of the people that live on Earth, it would add up to a size larger than the Earth, which means in order to sustain our average lifestyles, we are depleting natural resources. We are depleting our natural capital in order to do so. We have to keep making deductions from that ecological bank account. And the size of ecological footprints is not evenly distributed. The world's most highly developed countries have about 20% of the human population, but they use 86% of the world's resources. Whereas the rest of the world, which has 80% of the world's population, the vast majority of the world's population, uses only 14% of global resources. You may recall when I mentioned population growth in the first video, I said that doubling the human population would not necessarily double our impact on the environment, and this is part of the reason why. In the areas where the population growth is the fastest, the resource consumption per capita is the smallest. To drive this point home, these are two median households. One a median household in India, the other a median household in the United States. Median meaning that if we took all of the households and arranged them in a line by income, and we went straight to the middle of that line and we selected a household, this would be approximately what that household would look like. And they have all of their possessions arranged out on the front yard. And you can see that one family requires substantially more products to sustain their lifestyle than the other one does. I see an oven down here in this shot. That oven is made out of metal. That metal had to be extracted from a mine that had to be processed in a refinery. That created excess waste. It had to be transported from here to there. Each one of these products has a large environmental footprint attached to it just in the production from getting it from raw materials down to the end user. So you can imagine if you were to add up the total environmental footprint of all of these products, it would be a pretty sizable amount compared to the photo on the left where it would be pretty small. The average ecological footprint worldwide for just any average human would be about 2.2 hectares, and hectare is a unit of space that ecologists use a lot. It's a little bit over 2 acres. In India, the average per capita environmental footprint is going to be 0.8 hectares. But in the United States, it's about 9.4 hectares, which comes out to about 23 acres per person. That's the size of the island that you would need to occupy in order to maintain the average American's current lifestyle. And it notes here on the slide that this is twice what domestic resources can support. If we were to add up all of the ecological footprints of every person in the United States, even though the population in the United States only comes out to about 4% of the world population total, it would be about twice the total landmass of the United States. So that's how many resources we utilize. And at first that you would think, wait a minute, how could we possibly be using more resources, like double the resources than our entire landmass can supply? We import resources from other locations, so we import virtual space in order to meet those needs. So the main driving factor behind natural capital degradation is not overpopulation, which does play a role, but it's resource consumption, and the resource consumption is highest in the most well-developed countries. This next chart I really like. On the x-axis we have total population of a country, and then on the y-axis we have the per capita ecological footprint. And therefore the total size of a rectangle that you see here is the total ecological footprint of that country, because you're multiplying the population by the average ecological footprint of the citizens. And you can see that the United States has this tall, thin ecological footprint because we have a pretty small population, but each person in our population requires a lot of resources to maintain our lifestyle. Whereas if we compare that to China over here, the overall size of the rectangle, if we were to imagine standing this up on its side, is similar, but it's almost flipped in its dimensions. They have a much larger population, over 4 times the size of our population, but they have a much smaller per capita ecological footprint. So they have way more people, but a similar overall ecological impact. And then you can compare India over here that has a very small rectangle, even though it has a population closer to that of China than it does to the United States. Now, the reason why we are pulling these natural resources out is to make products. And whenever you make products, you create emissions, frequently CO2 emissions. So you can actually use carbon dioxide emissions as a kind of proxy for measuring overall environmental impact of a country or environmental footprint of a country. So here what we have is a chart that's changing over time as it measures CO2 emissions starting from the 1970s and going into the 2010s. Now, you probably aren't surprised to see that the United States is the largest section here. What's happening is the more CO2 emissions that a country has in a given year, the more it's being inflated. And because it's trying to maintain all of the borders, it looks a little bit distorted as it goes. But the larger a country is, the more of an environmental impact that it's having. But what you might notice is that China starts out very, very small, but their overall size on this chart increases as their economy begins to change, as they do more manufacturing, as they produce more and more emissions, and as the average lifestyle of a citizen there begins to increase. So to close out this video, take a look at this slide, which shows each country with a size that is distorted proportionate to the ecological footprint of its citizens. Then consider that as of today, spring semester 2022, there are 7.9 billion humans on planet Earth, only about 329 million of which live in the United States, which is 4.16%. This perspective can allow us to get out of the tragedy of the commons type mindset, because no longer will you think, well, my individual contribution, my little bit extra that I take isn't going to make that much of a difference. Instead, you think, wow, only 4% of the population is taking this much of a share of the resources. What can I do to reduce the amount that I personally am taking from the environment? And if you are in a position where you are able to research which products are less environmentally impactful or just use fewer products, I would encourage you to do so. Not everyone is going to be in that position.